All right, all right, all right, all right. All right. So, good evening, everyone. We are live on Facebook. So, we're going to go ahead and jump in, talk about how to tap into our math genius. I am Lanisha, joined by Professor Akil Parker. And you know how I like to do, like to start it off with you introducing yourself to the people.
My name is Akil Parker. I'm the founder of All This Math with a mission to improve the relationship overall between the Black community and mathematics. We create resources, books, similar to the book that Lanisha just came out with. Um, and we also have maintained a YouTube channel where we have almost 800 videos ranging from arithmetic up to calculus. And we just reached, like, over the summer, we hit 5,000 subscribers. So, hop on the bandwagon, believe the hype, and like, subscribe, and share. And I'm a father of three. You probably heard me talking about my daughter, the middle child, just now, how she won't teach me how to dance. Um, but I love her anyway. And I got two boys also.
Yeah, I'm gonna need your love not to change because she won't teach you how to dance. But thank you for putting that in there. All right. So I am Lanisha. I am the owner, operator of Bud and Bear Fruit Education, and I just want to make math happen for everybody. And one of the ways that I do this is by bringing us together. We usually have Brother Dana Harris with us on tonight. He's out there on the sidelines coaching his son in football. So we're hoping that he can jump on and let us know that they got that win. Um, but yeah, we're coming together so that we can increase student performance through community engagement. And tonight is no different than any other time that you guys have joined us. We're tapping into your math genius, and we want to start off with our math buster. Okay, so tonight's math buster is the way we learned it was the best way. When I say that, Professor Parker, what comes to mind? The way we learned it was the best way.
A fixed mindset.
Okay.
Fixed mindset. You can't really know that you can't really even know if your way was the best way until you learn other ways, at least one other way, because you got to be able to do the comparison. You know,
Mm.
um, it's kind of like when people say it's kind of like when people say college is unnecessary, but they haven't been to
Never
college.
been. Yeah.
So it's like if you've been to college, then I mean, I still would probably have some disagreement in terms of what makes it unnecessary, or at least have some questions about what makes it, unnecessary and worthless when people say that. But at least if you haven't been, then you don't know. Like, you have to have a standard for comparison.
Right.
I think when people say it was the best way, that's the way that they're comfortable with. And a lot of people are naturally just uncomfortable with math. So if you try to introduce math to them that they're unfamiliar with, it, makes them itch and they start to feel uncomfortable. So they may make claims like this, like, as to, like, it's a way to, like, silence any desire to embrace other methods.
Mhm.
Say, well, this is the best, so why would you even concern yourself with any other method if this is the best anyway? But how do we know that that's the best? And I think a lot of people, if they learn the other methods, they might realize that that way that they learned years ago that they liked so much, now they don't like it as much because now they have something to compare it to.
Absolutely. Yeah. Um, I put this in here today because I was thinking about how people who were taught in the way that I was, probably the way you were too, where it was just heavy in procedures.
Hmm.
And they're like, why we got to do all that? Somebody has shared a video with me on TikTok where a teacher was in her classroom and she was like, when we used to do 9 plus 4, we would do 9, 10, 11, 12, 13. She said, but now they got the kids decomposing the four. Well, she didn't use that language, but that's essentially what she meant. They were decomposing the four into 1 and 3 so that they can
Hmm.
make the 10 and
Yeah.
add the 3 to get 13. And she was like, I don't understand that. And she had, like, the video went viral. It had like 200 plus likes and all these people in the comments, like, it just seems pointless. I probably would have decomposed in 2 plus 2. So I would have got it wrong anyway. And so I'm going through the comments and I did reply to a couple of people, but then I was like, do I really want to invest my time responding to people who are probably very fixed in their thinking? So I didn't. But I think that people feel like the way that they learned it is the better way. And the way that we are teaching it today, or the way that their kids are learning it today, is extra, it's unnecessary, it's going what Dana used to say, around your elbow to get to your
Get
nose or
to your
something like
thumb. You around your elbow to get to your
that.
thumb. Yeah,
There you go.
yeah, yeah.
So
Because they don't.
what's your thoughts on that?
I think they don't understand. Like they do ask the question. They say, well, like, what's the point of this,
Mhm,
right? And they don't know what the point is, and there are a lot of reasons for it. It develops a better conceptual understanding of math. Generally, it develops number sense. It, when we think about like using 10 as a foundation for our mental math and our computation, that helps you understand the base 10 system better,
mhm,
right? Which helps you understand place value better. And when you understand place value better, then you don't end up saying like silly things that we see often, like somebody saying, well, if I got, $100,000, if I got $1 billion and it's a billion people in America, hypothetically, then that means that I should be able to give everybody $1 billion. Like, no, that you're not considering place value. You obviously are confused about place value. But a lot of that goes back to not understanding like the importance and the significance of the number 10.
mhm.
So if you're doing the number bonds and everything, and then like even with number bonds, like number bonds, that's gonna help you in chemistry years later because you're gonna have chemical bonds. You know, it's just gonna help you in a lot of things. But factoring when you get to higher levels of math, it's really all these things are helpful.
Right.
People don't know, so people don't know the value of it. Oftentimes, they don't get told what the value is. And even if you were as a child, if you're told what the value is, you might not still understand. It might go over your head what the value is. But then even like, the question becomes like, but well, I would say this, it goes back to our fear and our discomfort with math generally, because on the one hand, it's like, why do I have to tell you like what the purpose of it is? There's so many things in life. And I think it is valuable to understand the purpose, but at the same time, when we examine and seriously think about a lot of the things that we as people, grown-ups, grown men and women, that we just do just because somebody say do this. We don't never ask no questions. Like, why is it that with math, it's always like, well, why I got to do this for? Like, whoa, but you wasn't asking him like why you had to do that thing because
Right.
when you saw your favorite celebrity doing it, you just wanted to jump on the bandwagon and go do it. You ain't ask them type of questions,
Mhm.
right? You just trying to like live a certain lifestyle. You think that's gonna make you happy or whatever. Like, but you're not asking those types of questions. But when it comes to math, all of a sudden everybody got a whole bunch of questions. Like, oh, why am I doing this? What are we doing with like? And I'm all, and at the same time, I'm all for people having an inquisitive nature. I
Right,
think
right,
that's very healthy. But it's not an inquisitive nature when you're only asking the question so as to silence the effort or dismiss the effort to do something different.
right, right, right.
That's not being inquisitive.
That makes me think of Deborah Pert, what she says about people thinking or people living as if math is optional. Like you
Hmm.
don't ever hear people go around and say, I ain't no reader. like I ain't no reader. I can't read. Like people don't say that and then have a whole bunch of people agree with them. But
Right.
it's very easy for you to go into a crowd and say, I ain't no math person, and you'll have about 5 or 10 people that's gonna jump right on the bandwagon with you. One of the things that came to mind for me when I was watching the girl do the video of the 9 plus 4 was the skill that we want kids to have about decomposing and rearranging. So you know how when they get into middle school and they start to talk about geometry and we want
Mm.
them to be able to decompose and take things apart. It's the same thing. Like we're getting them prepared for that. So if we're saying we don't want them to critically think in primary grade levels, well, what do we expect is going to happen when they get to middle school? Like it's that is not just going to show up. That skill is not just going to show up out of thin air.
And you know
So
what
that
else? Well, let me
go
let
ahead.
you, let me let you finish. Let me let you finish.
No, I was going to say that was going to be a perfect segue for us to talk about those standards for mathematical
Yeah.
practices, like the things that we're expecting kids to do in the classroom. But go ahead
And
and share your thoughts.
I think too, it's like just generally speaking, just about mathematics in general. Like sometimes math can be difficult. especially if you're unfamiliar with the topic that you're being presented with, or if it's a new topic, or and that's okay, But what happens is like people often say like when they approach the difficult math problems, they don't see the connection, they don't see the value in it. But what you have to realize is like as if somebody gives me like a difficult like pre-calculus word problem that I've never seen before, like a type I've never seen before, and I'm like, yo, how am I supposed to do this? I never, but I'm sitting there and I might get a little frustrated myself, and I'm looking at it, I'm reading it over and over again. I'm trying to figure out, okay, well, what type of problems am I familiar with that seems similar to this? Like it's that's just general problem solving. That's just how, and then at the same time, like, because I'm thinking like the same type of stress and discomfort that you might feel when you see that math problem, that word problem, and you have to figure out how to solve it. It's the same type of stress that you feel in an everyday situation. Like you might have a conflict with your baby mom and you trying to figure out, okay, well, I got this much money and the kid need diapers, or but I'm trying to go here and I got to figure this out. And or maybe we not together no more, but I'm still kind of messing with her a little bit, but I got a new girl over here now, so I'm trying to figure out, okay, how do I maintain peace in my life? Like that's a real life problem. The same way you try to figure out how to maintain and manage and navigate all that is the same. It's the same feeling you're gonna have when you're looking at that pre-calculus word problem. And I would argue that, or I don't want to say argue, I would say I would submit that if more of us, when we was in high school and we was looking at them pre-calculus word problems, if we persevered, right, through the productive struggle and worked to figure them out, we'd have more practice with solving problems generally. So then when you get into the situation later in life and you got the baby mom and you got the kid and you got to like, provide financially for some things, but then at the same time you got another girl you trying to deal with, but you still kind of messing with your baby mom and you trying to figure out how to navigate all that, you'd be better at figuring it out because it's really the same. It's a skill set of like, okay, how do I solve problems? Because problems are problems, no matter what area of life they arise from. A problem is a problem, and a lot of people just lack problem solving skills.
Right.
And we see that all the time. Like, okay, this is the result. Like, especially when something escalates and it get crazy, right? You're like, okay, if we look at the timeline on this situation, like when did this start? And we look back at the beginning, it's like, and then for some of us that do have problem solving skills, right? Like some people in your family might have problem solving skills, and they be looking at you like, well, why ain't you just do this? Why ain't you
Right.
just do that? Why ain't you just do this? Why ain't you just do that? Why ain't you just call this person? Why ain't you just... And then you sitting there like, well, I ain't even think to do that,
Mhm.
right? Because you don't have problem solving skills.
Mhm.
And that's the like one of the hidden values of math and math classes is like you're really being trained how to solve problems. And
Mhm.
so many of us are like, well, this is irrelevant. I'm never going to use this. And like, unfortunately for a lot of us, you're right. And you're never going to be able to solve problems. As you'll be a grown man, a grown woman that does not know how to solve problems. And that's what happens, unfortunately, for so many of us. So I just wanted to put that up. I was thinking about that today, like how relevant math is, because it's not even about the formula. It ain't about y equals mx plus b. It ain't about Pythagoras. It ain't about the quadratic formula. It's about being able to solve problems. Because if you can
Mhm.
solve problems in one area, you can solve problems in any area.
Right. Right. So great segue into our first question. So our first question tonight is, what is the challenge with making sense of problems and students persevering in solving them? So what do you think is holding kids back? And you can even tie in adults if you want to, in making sense of the things that are being presented to them.
I would say even if like for me, when I was younger at times, like a fear of being wrong and the
Mm.
reaction you get from being wrong and being identified as the person that was wrong, being laughed at in class or something like that, um, or being in an environment where there's a teacher that doesn't really nurture that type of environment of
Mhm.
appreciating mistakes and
Mhm.
experimentation in a math class.
Yeah.
But I think also too like you mentioned earlier, like the way in which we were taught, like very much process driven, very much like steps oriented. It wasn't really about like, it's like, well, if I give you the steps, my expectation is that you're going to memorize all the steps and then
Right.
just regurgitate the steps or just follow the steps. So then it's almost like, well, there's no excuse for you to get it wrong. You just didn't memorize the steps quick enough and didn't
Mhm.
apply them properly. So I think we have to have environments in the classroom where not only the classroom, but also like at home where, when parents as parents and grandparents and uncles and aunties, when we like interact with children in our family, like you got to create that environment where they know like asking questions is a good thing
Right.
and a positive thing as part of the learning process.
Mhm.
And then, them being wrong is like, okay, everything is a teachable moment.
Mhm.
So I
Yeah.
think those are major challenges.
Yeah, absolutely. This is gonna sound left field, but I'm gonna bring it up anyway because I feel like you'll be able to see where I'm going with this. I have become obsessed with this show on social media called Pop the Balloon or Find Love. Have you
Hmm.
ever heard? Okay,
Yeah,
so I
yeah.
can't remember the girl that does it, but she has like millions of followers on YouTube. And so she has this line of people up there and they come up there. And the reason why I'm thinking about this is because there's some people who come up there and they get asked a question and they stumbling, like they can't answer it, they can't formulate, articulate their thoughts. Like I can see, like I can picture the little wheel in their brain just rolling, but nothing is coming out. And so it just made me think about how I don't know if it is just nerves for them or if it is a lack of experience. Like you haven't been in positions where you've had to explain something about yourself or share something about yourself to this degree. And I'm thinking and comparing this to the math classroom where we
Mhm.
don't provide students with enough experience. And then when they get to a certain level, we're now expecting them to analyze and be able to articulate these thoughts and to critically think about things when they haven't had enough practice. So when they say, I don't know how to explain it,
Mhm.
or I don't know what to say, it's legit. Like they
Yeah,
really don't,
yeah.
because there isn't enough experience to kind of help them get to that point, to help them formulate a response.
Yeah. Yeah, I wholeheartedly agree with that. And so when I've noticed that, one thing I'm adamant about, and I know a lot of the students that I tutor, I know it annoys them, but it's gonna make them better, right? When we're going through problems, I'm always asking them like, why?
Mhm.
Like, why'd you do that? Like, like, because one of the things is I got to teach them like this idea that just because somebody questions you doesn't mean you're wrong. Number
Right.
one, and also it helps you to stand on business
Mhm.
because if you did make a decision, you got to stand on that decision,
Right.
right? And he's like, okay, well, if I decided to divide by three, tell me why you divided by three. Tell me why you thought that was a good idea. And I think also it's a life skill too because it teaches accountability.
Right.
Because now I'm questioning you, and now you got to really sit and think like, well, damn, why did I do that?
Exactly.
Like, does that even make sense? Like, I was working with a young lady today, and she made the mistake of it was like three plus the quantity. No, x plus the quantity of x plus three, and
Mhm.
she went to the distributive property because she saw the
Mhm.
parentheses,
Mhm.
and I'm like, what you do that for? I'm like, why you multiply? And it's like, oh, because it's parentheses. Oh, really? Okay, but what about that plus sign right there? That plus sign is right there though. So what does that mean? That means you're still supposed to distribute? And then they're like, "Oh, nah." I was like, "Yeah, so you got to remember that." Oh, but and then it got better. You know why? Because well, I mean, this is a little off topic, but she's a college freshman and she's taking like a college algebra class, and I was like, "Listen, you can't let these classes psych you out because if you go into these classes, these math classes in college, like thinking that they're hard, you're gonna think they're hard, and it's gonna cause you to shut down, and you're gonna start making careless mistakes." Because at another point in our session, she was solving an inequality, and it was like she had to do like ended up with two minus one. And she said -1. And I'm like, sis, two minus one? Like you knew that when you was in first grade. You know that two minus one is one. But because you looking at this like, oh, this can't be this easy. This
Right.
is a college class.
Mhm.
You getting psyched out. You letting it knock you off your square. Because you're in your
Yeah.
mind, you're like, this is so hard. And
Yeah.
like you can't do that. You gotta like just take it one step at a time and just work through and just like it's almost like with sports, you gotta like play your game. Like don't get intimidated because this other team that you playing against is like ranked in the state or ranked nationally. Like you're good too. Just because you're not ranked, that don't mean y'all can't beat them, right? But if you
Right.
let that get in your head, like the same, like in a math class, you like, oh, this class is so hard. Then you start making like dumb mistakes. Like it's like, come on, you know that. You know two minus one is one.
Right.
But it happens because you get emotional.
Hmm.
And then you get like your cognitive ability gets compromised.
Right. So the standards of mathematical practices are basically like this system or these skills that we want to see kids exhibit in the classroom, things that we're supposed to help them build. So I wanted us to talk about this, even though we are most of the time we're talking to parents. I want us to talk about this so they can understand maybe how they can even do this at home. So this first one is about making sense of problems and persevering. So like sticking to it, not giving up. Okay, so I want us to look at something and I want us to think about how could we make sense of the question. So they give us a number line. There's 0 and 1/2 on the number line, and then the question is, where is 4/3 on the number line? So I want us to think about how can we make sense of this? How can we make sense of what they're asking us and the image that they've given us?
So I have a question. Now,
Yep.
I have a question about what type of prior knowledge, if I'm playing the role of a student looking at this, or
Mhm.
even a parent, what type of prior knowledge do I have about fractions, mixed numbers? Do I have any
They
or
should know because this is third grade, so they should know like unit fractions.
okay, okay.
Yeah, so they should have some idea of the number line. Remember, we did our series on the number line where they've been using this for a while. By the time they get to third grade, now we're kind of expanding it so they can see those numbers in between the whole numbers. So
Yeah.
yeah.
So if I know like thirds, I'm looking for 4/3,
Hmm.
right? And
Hmm.
again, to the parents that's out there, like when we see a fraction, we should say it like that instead of saying 4/3.
Yes.
Because if you say 4/3, it doesn't really emphasize like, what the denominator really means.
Right.
It's like 4/3 just means it's just a random number. Like you just got a written over a three. But that three means you got thirds, and the four tells you how many thirds you got. So it's almost like with money. Like if I got $4, I
Hmm.
got dollars, I got US dollars, US currency, and I got four of them. So that's why it's $4. So this is like 4/3.
Hmm.
So it's a few ways I might look at this. Like I might, well, do I know that 1/3 is less than 1/2? Do I know that?
So
Um,
that's what we want to think about. That's one of the things that we want them to think about. So they could be using take diagrams. They could
yeah,
be, like they could have some physical fraction manipulatives to help them out with this. But I want us to think about like as a student is looking at this problem,
yeah,
what questions should come to mind? And you just brought up a good one. Is 1/3 greater than or less than 1/2? Great
yeah.
question.
So also like I might think of like, well, where's a whole at? Where's one at? Because I got 0 and 1/2. So where's one at? And then if I'm thinking like, well, I know 3/3 should be equal to one.
Mhm.
So if I can find one by using 1/2, so
Okay.
half of one is just that, it's half.
Right.
So that what that 1/2 is like a midpoint,
Hmm.
and that's like the halfway mark between 0 and 1. So then I draw where the one would be at,
Okay.
and I
So
also know that
did that look
the
about right?
yeah, that looks good. Yeah, yeah.
Okay.
And I also know that one is also 3/3. So I'm looking for where 4/3 would be at. So then I got to think, well, another third. So how much space would a third take up? Um, I guess if you wanted to get like, if we wanted to get not, I don't want to say fancy, but maybe a little advanced, like we can get into common denominators
Okay.
with the 1/2, with the 1/2 and the 4/3, and say, well, what's the common denominator between 3 and 2? It would be 6.
Okay.
So 1/2 is the same thing as 3/6.
Okay.
So that means we're breaking everything down into sixths.
Okay.
And then 4/3 would be 8/6.
Okay.
So we could do that. So if I broke a half into 3/6, then that means the space in between 0 and the 3/6 would be three equal spaces.
Hmm.
So then I just draw three more of them to get up to one. That's
Mm-hmm.
another 3 6. And then I draw one of those. No, matter of fact, not one, two more. Because 8 6. Because 4/3 is equivalent to 8 6.
Mm-hmm.
So I gotta draw two more of those hash marks after the one to get to 8 6.
Okay.
It's
So
another way to do it. But I'm just wondering, like, would a student know to do that if they haven't been taught that explicitly? I don't. I'm wondering if I'm in third grade. I don't know if I don't know. Maybe I'm not giving myself enough credit, but I don't know if I would have thought to do that when I
okay.
was in third
So
grade.
the first thing that came to mind for me, like even if I'm trying to figure out this whole number line thing, like I know one whole, right? And then I know what one half is in terms of one whole. And so then if I think about it in terms of thirds, then I know I should have something like that. That's a
Mm.
little
Oh
off.
yeah, right. You did. We did that before. You did the tape diagram, the stacked tape diagram
Mm-hmm.
to see the relationship. Okay. Yeah.
So
Yeah.
then I would reason that 4/3, like you started, you said 3/3 is going to be at one. So 4/3 would have to be on the right side of one.
Right. Right.
That's what I would reason. So I think for this part, just talking about what is going to go through a child's mind. So like all that you just thought about, you thought about equivalent fractions, you thought about one half in terms of one, you taught about the unit fraction, you talked
Hmm.
about how many of the unit fraction we had. Like there was a lot of things that went in your mind, like how big is this in compared to this. Those are the things that we want going through the child's mind as well. But I think the challenge is having the kid to actually persevere in that. And maybe they might give up because they don't know. Maybe because they're so used to saying 1/2 or whatever the case may be, that they have no concept of the value of it. So then when you're comparing, I don't really know where to start. So I want to think about how can we get kids to actually go through that process, like stick with it, and like even if you need to talk out loud, okay, I know 4/3 is 4/3. So then this in comparison, we need to get kids to do that. How can we get kids doing more of that?
I would
What?
think so. One thing is like if we did an example, like let's say like as the teacher, we did the example where we
Mhm.
did okay, where's 4/3 on the number line, and then we gave them some practice, like okay, well where is 8/5 on the number line, and like gave them the same number line with the like hat 0.5, and then hopefully they use that as a guide.
Mhm.
Um, well, I'm assuming that that's already happening because that's the I do, we do, you do model, right?
Mhm.
Um, but to your point, a lot of times children still don't have the perseverance, even if they have like an example was worked out. Well, I think sometimes too, teachers don't really know when students don't understand or what specifically they don't understand. So they don't really know how to explain
Yeah.
um, or what parts should be explained specifically
Mhm.
or what parts they should lean into, so to speak, when in their explanation. And a lot of times that comes just with experience,
Yeah.
just knowing, and then knowing your particular students. Um,
The interesting thing though, you said I do, you do, we do. That's likely how most people were taught. In my district, we do you do, we do, and then a synthesize. So you start off giving students a chance to explore a concept.
right.
So looking at it and seeing if you can make sense of it, then we might partner you up with someone so you guys can compare what you've done. And then we bring it all together. And then the teacher who is on point where her teacher moves, she's moving around the room and she's listening for some of the vocabulary, some of those strategies that she wants to highlight for the whole group. The problem is when you're starting them off at this explorative state, and I don't have a lot of the foundational skills. So now I'm just sitting there twiddling my thumbs because I really
Yeah.
don't even know what to do.
yeah, you gotta bring something to the table. And like I would, yeah. So if you're not, well, I guess if you're socialized, in educational spaces and all your educational career, you've had that experience where you start
Mhm.
out like just explorative and just like a discovery model, I guess,
Mhm.
then it's different. But if you're a person that's more accustomed to like show me how to do it first, and then we'll do it together, and then I do it on my own. That would like frustrate a lot of people. Like even like I'm thinking like with me, like I like for people to show me things. Like I want you to show it to me explicitly. Show me how it's gonna be done. Um, and I mean, even like yeah, I just been socially conditioned that way. Like even like as a child, like growing up, like sometimes when my mom was very strict about like certain chores or like things she would ask us to do, and I would be frustrated if I felt like she didn't provide good instruction, and then I'd be mad because then it's like I'm getting in trouble for something. But I'm like, whoa, but you ain't really tell me how to do it though. Like you
Yeah.
left out these details that you assumed I was supposed to know, and I
Mhm.
really didn't know. You know, but yeah, that model is like. But again, if they've been socialized into that, integrated into that type of model where they're used to just trying stuff, or at least they're expected to just try stuff on their own from the beginning, then
I think,
that's different. But they need confidence though. You need confidence, like to
yeah.
try stuff, to be just experiment.
I think there's a place for both of them. So, like you said, if your mom told you to do something and she's expecting you to know how to do it, but you really don't know how to do it, an example is like today, Corbin wanted to go down the street and go to the boxing gym, but he also knows he needs to study and he knows that he has to do some basketball workout. So I said, if you go down there, I'm gonna let you choose. And then he was kind of having a hard time choosing. I said, if you go down there, this is the time that you're gonna get back. And then this is the time that you're going to finish this. And then this is the time that you're going to do this. So this is the time that you're going to finish everything. Is that the time that you want to finish your night? And he was like, okay, no. So then I'm not going to do that. I'm going to switch it up. So it took for me to kind of lay out those steps so he could see it
Hmm.
versus him doing whatever he felt in his spirit he needed to do without really processing it fully. So that's why I
Yeah,
say I think in some instances you do need to kind of let me lay it all out for you. Whereas others, it's like you're trying to build that thinking classroom concept where you don't want a classroom full of robots waiting for you to tell them what to think and what to do. You
yeah,
want to
yeah,
have
yeah,
some
yeah,
that are able to kind of start on their own. But like you said, if they have been trained, I guess, to do that, it's a different story. But if
yeah,
you have a period of time where everybody is doing the gradual release and now you come to me and I'm doing rapid release, there's going to be a disconnect. And then you probably going to be sitting there doing nothing.
yeah, yeah. I
Mm.
know that. I know that feeling. Yeah.
Whew. Okay. So the first one was making sense and persevering. This second one is about constructing viable arguments. So the question is, how can we build a child's ability to construct viable arguments and critique the reasoning of others? So this is another standard of mathematical practice, something that we are expecting kids to do in classrooms, a skill that we're trying to develop within them. So how can we build a child's ability to construct these things?
Oh, I'm gonna say, something that I said earlier. I'm gonna just reiterate that. Like one thing is question and challenge their thought processes whenever they're answering questions, whenever they're solving problems, and just ask them like, well, why'd you do this? You
Mhm.
know, why'd you take that step? Why'd you add four? Or why'd you draw this that way? Like, why did you do that?
Mhm.
And force them to explain, because before they explain it, they got to think through what they were doing. Why did they do that? Because they got to know that. They got to be thinking like, well, this is why I did this. Or sometimes they might realize, well, damn, I don't even know why I did that. Like, why did I
Right.
do that? Or I thought it was right, or I thought it made sense. Well, why'd you think it made sense? Like, you know, um, and get them used to and like accustomed to being held accountable for like, the answers that they provide. And also like error analysis questions too.
Mhm.
I think like if we like listen, I'm gonna give you or we could do a multiple choice question and we find what the right answer is, and we talk about, well, why is that the right answer? So we already had that conversation, but now let's talk about why those other three answers are wrong. If it's A, B, C, and D, like let's
Right.
have a robust conversation. Like, okay, why is A wrong? Why is B wrong? If C was right, why is D wrong? like, and really get you thinking about that. So then when you see, and then think about like, well, and also when it comes to like preparing them to critique the reasoning of others, as they're identifying why those questions, why those answers were wrong, like how could they have possibly, what might have led them to that answer? You know,
Hmm.
what might have led a person to get that answer? You know, um, and just I think just having consistent practice with that can build their ability to construct the arguments and critique the reasoning of others, and even let them know, like, because you know, like, this is like, you should jump at this opportunity, like, because children, people just like to argue anyway. People just like to prove people wrong anyway. Like, y'all argue about everything else anyway. Y'all might as well argue about math.
Hmm. Yeah. I had a thought the other day. So you know how we always want the kids whenever they're doing math, most people want them to do it in pencil, right? But I had a thought the other day because I know you like to do your math in pen.
I love it.
And I was thinking,
I
I
love
was
it.
like, you know what? We talk about kids doing their work in pen because it can be messy. Like we know it can be messy.
Hmm.
But I wonder how impactful it would be for instead of us erasing the incorrect work or whatever the case may be, if we left it there as a comparison to what was correct.
Yeah,
So, I mean, yeah, you could do error analysis like you're looking at other people work or whatever, but now looking at your work so that you can see this is where I started. What did I do differently in order for
right.
me to get it correct? Because if we're expecting kids to learn from their mistakes or we're expecting them to grow, but all the stuff, all the mistakes, the stuff that I could have grown from, I erased it.
Yeah, it's like it never happened.
It didn't happen. It's gone.
Yeah,
I had that thought the other day. I was like, oh my gosh, maybe we need to be writing in pen. Maybe not writing in pen, but
and that wasn't, that's not my reason. I just like the way pens flow better on the paper. I just,
I
it's
see.
more of a, it's a better feeling for me. I just like,
Okay.
I like pens better. Like, but and I don't like that scratchy noise that pencils make sometimes. It remind, it's that for me is like how, with some, how some people feel about nails on the chalkboard.
Mm,
That for me, like, I don't like that sometimes. But but yeah, I think but yeah, them being able to see their work and see their progression, and but again, that's a mentality. Like, even seeing like a mistake, because you could look at it, a wrong answer, as a mistake, or you could look at it as a progression, as a part of the process. For a lot of us, the way we've been conditioned, a mistake isn't just a mistake. It's something to be. It needs to be erased. It needs to be avoided. You want to act like it never happened,
mm,
right? Just like a lot of times, like, we have, you know, experiences, and we want to act like, people, like, you might try to reinvent yourself, like, move, instead of saying, well, this is how I used to be, I've grown, I'm in a different season of my life, I'm more mature now, I've learned from my mistakes, but my growth can only be seen if I acknowledge where I came from,
mm,
like who I was before, like, what I was doing, like how I used to be, back then. But I don't know, like, it's like a mentality. Um, yeah,
mm-hmm.
because you can look at it as a mistake, or you can look at it as like a lesson, or like part of the process. And hopefully
Absolutely.
you learn from it. That's
Yeah.
another thing too. Like, hopefully you learn from the mistake, like, you know, and continue to grow and actually make progress, instead of, because some people just make the same mistake over and over again. They don't really learn,
Yeah.
but yeah, but I think that
Um,
is a mentality. A mentality we have to, like, in terms of math class, we got to say, like, to get children to like embrace mistakes, and even parents, like, so I think that's part of the challenge with, I think we talked about this before, like, with parents being uncomfortable with the math and helping their children with homework, is because the way they view mistakes, because they're like, if I try to help you with this, they may not articulate this, but if I try to help my child with this, and this is something that I don't think I'm strong at, I'm going to end up making a mistake, and I don't want to make a mistake in front of my child,
mm,
because then that compromises my position as an authority figure, because I'm supposed to be the one that got all the answers.
mm,
So if they bring home homework and then it's something I don't know how to do, then I'm not about to get exposed. Like, my son and my daughter's supposed to think I'm the know-it-all. I know everything. Like, daddy knows everything, mommy knows everything, and I'm supposed to, like, that needs to be my reputation. So this math homework is gonna compromise who I really am. It's gonna expose me for who I really am. I'm human. I don't want these kids to think I'm human.
Ooh, not you a superhero. That just made me think of a comment that James Clear made in Atomic Habits. He was talking about how when people deal in absolutes, like if I am, let's say I'm a award-winning basketball player, and that's how I identify. Like, who are you? I play basketball, but then something happens, like I get hurt, I tear an ACL, something gets torn up, and I can't play anymore. Now I'm going through this whole identity crisis because I have identified with this specific thing, and now I can no longer do it. And so now I don't know who I am. And so I think we have to be a little bit more flexible. I share that because we have to be a little bit more flexible. Maybe you would consider yourself an athlete or somebody who is, I don't know, active. I don't know what vague term you could use to describe yourself in that specific example, but the flexibility of it is what I think we need as parents. Like you can't be all powerful, all knowing because it's not true. Like that's just not our reality. Nobody knows everything. And I think showing that vulnerability, showing that you too makes a mistake makes it easier for your kid to be willing to take the risk in the classroom or to be willing to take the risk in front of you so
Yeah.
that they can learn. So we
Hmm.
got to be a little bit more flexible in who we are with our kids. All
Yeah.
right. So the next question, I'm going to skip a slide and then come back. The next question is about reasoning abstractly and quantitatively. So this is another mathematical practice. What we want and expect kids to be able to do, reason abstractly and quantitatively. What does it mean to do these things?
So I don't have as good of an answer for reasoning abstractly, but for quantitatively would involve like what, like how many of something we're dealing with, like how many fractions, how many numbers, how many objects we
Mm-hmm.
have.
Mm-hmm.
To reason abstractly is like, isn't that like that's like conceptual, right? Like just the concept behind it.
So remember when we did our concrete representational abstract session,
Yeah.
where we went from hands-on with the manipulatives to drawing pictures to the abstract. The abstract is like your formulas, your
Okay.
rules,
Yeah. Okay.
things like that. So if we want them to be able to reason abstractly, we want them to be able to represent things using symbols,
Hmm.
right? So instead of you having to add something a million times, understanding that you can multiply it
Hmm.
or something like that, that kind of consolidates your thinking or simplifies it.
Like okay, so like formula the perimeter of a rectangle, P equals 2L plus 2W.
Mm-hmm. Yep.
But quantitatively would be I just identify the length and the width of the rectangle and I add them up. I add the length plus the other length plus the width plus the other width.
Yep. So you looking at those quantities and whatever that relationship might be. So I got an example for this one too. So this one is fourth. Each student in class needs 3/8 cups of flour to make modeling clay. If there are 15 students in the class, how many cups of flour are needed?
So you saying how should we do this?
So we're reasoning abstractly and quantitatively. So we need to first make sense of the quantities and the relationships within the problem. So how can we model for anybody who's watching how students could make sense of this and reason about the quantities that's within the problem?
Can, can I also ask a question too? Like in terms of like with any word problem, I always want people to make sure they understand or have an intimate understanding of everything going on inside the problem. So like I would want to know like what exactly is modeling clay? Is that like on the movie Ghost when they was doing the scene with the thing with Patrick Swayze and Demi Moore? Like, is that modeling clay or is that something different?
I haven't seen that movie.
Okay, okay. Uh, that's right. I'm a little older. I'm a little older than you, I think. That's
I've heard of the movie, but I just never watched it.
okay.
Yeah.
It's a
So
it's a cult. Supposedly it's a cult classic, but I mean you ain't miss a whole lot. I mean it's all right. It's all
okay.
right. But modeling clay. So I want to know like what modeling clay is. And like what do we use modeling clay for?
It's used in sculpting.
Sculpting. Okay. Okay.
Yeah.
So making a sculpture. Well,
Mm-hmm.
15 students in the class, everybody gonna make their own sculpture. Maybe it's
Mm-hmm.
groups, maybe it's individual sculptures. That
Mm-hmm.
seems cool.
Okay.
Um, oh, is it the thing where they do the thing with the they use the newspaper and they like make the mold and then they put the clay on top of it? Is it like that?
I don't know why you want me to be an expert in modeling clay. I just know that
No,
it's
it just it
debate
just
structure.
it makes me more comfortable with like with the problem overall. It like relaxes me like when I have a better understanding of like what's going on.
And that makes sense.
But abstractly, well, I'm like, okay, everybody needs 3/8 of a cup,
Yep.
and it's 15 people, so we could just do 3/8, count it out 15 times,
Okay.
3/8 plus 3/8, or we could multiply since we know multiplication is repeated addition.
Okay.
We could do 3/8 times 15, or we could do 15 times 3/8.
Mm-hmm.
We could do that either way.
Yep. All right. So is there, how would the student know that we could, aside from you just telling them that we can, that repeated addition is multiplication, how do they know the relationship between the 15 students and the 3/8 cups of flour?
Um, well, each student is gonna have three, it's 15 students. I mean, they could draw it out. They might draw a picture and say like, use like a tick mark for each student, bunch of like
Okay.
ones or hash marks, and then put 3/8 underneath of each one of those hash marks, and then just add them up.
Mm-hmm.
Um, I don't know. Maybe they realize like, okay, I'm adding 3/8 15 times,
Mm-hmm.
and maybe they're using the word times, and times associates with multiplication.
Mm-hmm.
Maybe that's why, or that's how they would see it.
Okay. So then they see that I could add this a whole bunch of times, but then they're like, dang, no, I don't need to be adding. Like I could just multiply. So let me just multiply this 15 times 3/8. Okay. Okay.
Oh, but you know what though, too?
Mm-hmm.
I would want to make sure that when they do 15 times 3/8,
Mm-hmm.
they don't make that critical mistake that a lot of people do. They don't multiply the 15 by the 3 and by the 8.
Mm.
That's a very famous error.
So let me see. So we know that 3/8 is the same thing as 3/8, right?
Right.
And then I can also put that 15 out there because we know we multiplying that.
Yeah.
So now I got 15 times 3 times 1/8.
3 times 1/8. So 45 times 1/8.
Mm-hmm. Or 45/8. Mm-hmm. Okay.
And then do they convert it into a mixed number?
Good. Yep. So I would love for a student at this level to understand that this is 45/8 and then understanding how many holes does that represent. So how many holes do we have in 45? Hopefully, hopefully. They got five. And then knowing how many eights are remaining. So we got five holes and then 5/8.
Yeah.
Mm-hmm.
The 5/8 part might be tricky for some people. Like, why? So 5/8 meaning, all right, so we have, so five groups of eight, five. So, okay. So 8/8 is a whole.
Right.
So we made 8/8 five times,
Mm-hmm.
but then we still had, I guess, okay, 5/8 left over because
Mm-hmm.
the 40/8 is five holes, and then we still have five. Okay, so yeah, that makes sense. Yeah, I guess you could just explain it that way. Like we got 5/8 left over.
Hmm.
So that's why it's five wholes and five eighths.
Yep, we got 5/8 of a whole, basically.
Yeah.
Yeah.
See, that's the concept. Like these are the things I never learned when I was young, like, or it wasn't taught or never learned, or a combination of both. Like I just knew I learned how to convert improper fractions into mixed numbers.
Hmm.
And I never could reason it out. Like, okay, well, why is that though?
Right, right. Some of my students had that aha moment this summer, like looking at converting between your improper and your mixed number, and it was like, oh, that's why we do. That's why we multiplying and we adding.
Yeah.
So I think it's just good to have those conversations, to slow down and have those conversations, and make sure that the kids understand what's going on. Because sometimes we throw things out with the expectation that the kids are following us, that they understand what's going on, and they don't. But they're gonna nod their head
Hmm.
and let
Yeah.
you keep
Yeah.
going and don't know nothing.
Yeah. That's why like as teachers, we gotta learn to ask the right questions.
That part.
The questions that when you can't fake it.
Hmm.
Cause I'm gonna ask you the question and then you're gonna be like, and it can't be like a yes or no question. It's gotta be, or I guess it could be a yes or no question, depending on what it is.
But that's
But
why I like work so much, because you can tell me anything, but your work, your evidence.
yeah,
Give me your evidence. You say you got it. Let me see. Show me. That's gonna let me know every time.
yeah,
Just like a kid today, they were talking about equivalent ratios, and the kid was like, we can use the butterfly method. And he went to the board. The teacher let him come to the board, and he drew a butterfly up there. He didn't know what to do. He was putting numbers and wings and all kinds of stuff. He
he
ain't know what to do.
he
I was
just
like,
he just remembered the butterfly. That was it.
that's all he
He,
remembered. That's
yeah,
it.
okay,
And
yeah,
that's usually what happens when we teaching these tricks. The kids remember that trick, but they don't know when to use it. No idea. All right. So the last one, we won't be able to get through all 8 tonight, but the last one that I want us to look at is the modeling. So why do you think some mathematical modeling is challenging for students and people?
oh, because a lack of conceptual understanding.
Mhm.
Because they weren't taught, for the adults, we weren't taught the so-called new math.
Mhm.
The so-called new math. Like the new math is like the model makes sense. Like if you learn it the way that it's being taught in contemporary times, like you can model it more easily.
Mhm.
Because just like with the tape diagrams and the math drawings and everything, like when I first like started teaching, like I didn't like all of that. I didn't like to draw the pictures and everything unless it was like a geometry problem where I had to draw. Okay, we're working with a triangle. Okay, I'm gonna draw the triangle and label the angles or label the sides or whatever. But with a lot of other things where pictures come in handy, I used to shy away from the pictures, but the pictures are great. I love the pictures because the pictures it makes it make sense for me. But I think
Mhm.
if you don't understand the concept, then it's difficult to draw what it looks like
Mhm.
if you don't really understand that concept, you
Okay.
know. Um
And with the modeling though, it don't always got to be a drawing per
a
se.
drawing.
Like it could be a table. Like I could
Yeah,
model it with, some type of rule or something. It don't necessarily have to be a drawing, but I think you're
yeah,
still correct though. I think people still, if I don't understand the concept, it don't matter how you want me to represent it. I still can't.
yeah. And speaking of the tables, that's a good point because when I'm doing like what is it, like maybe algebra 2, algebra 1, and
Mhm.
like the famous word problem that used to be in all the movies back in the 80s,
About the train.
like yeah, about the train. Yep. Like when you do the table for that problem and you organize the information, then it makes sense. It like almost like it gives you the equation. The different expressions for the equation is in the table.
Mm-hmm.
So then it's like, oh, okay. And then you can see, okay, do I add the expressions together or do I subtract one from the other or like what's really happening?
Mm-hmm.
Because it's all based on the abstract formula, distance equals rate times time. So if you understand that, then you know where to put everything. You know where everything
Mm-hmm.
should go.
Okay.
So
So this is our challenge with modeling. This is our last one. So Rafa makes himself a drink where he mixes 2/3 cup of iced tea with 1 cup of lemonade. One afternoon, he makes the drink for all 5 members of his family. What is the total number of cups of the drink that he will make for his family?
All right, so 2/3 iced tea. So it's not a half and half. It is a half. We call it a half and half, but technically it's not a half and half.
Ain't no on a Palmer,
Uh,
huh?
nah, like because so in Baltimore where I grew up, that's part of like the staple. That's part you get a chicken box,
Mhm.
salt, pepper, ketchup, hot on the fries, hot sauce on the wings, and a half and half. But you gotta tell them a little bit of ice. They
Mm.
try to give you a whole bunch of ice, so they don't give you as
The
much
drink.
beverage. Yeah, they try to get over on you. You gotta tell them. In the styrofoam cup that's bad for the environment. Yeah, that's
So you tell them no styrofoam cup?
nah. Back then, no, I just I didn't I wasn't thinking on that level back then.
Gotcha.
But yeah, but let me see. 2/3 cup of iced tea, 1 cup of lemonade. One after he makes a drink for 5 members of his family. So all right, so I would so we saying a model,
Yeah.
um 2/3 they're mixed together. So that indicates that we're doing 2/3 plus one. They're the same units, they're both cups. So 2/3 plus one for himself.
Mhm.
But if he's doing that for 5 people, so that would be a total of six, or is it 5 people altogether? Is he including himself in the five, or is
So
it
for his
five
family.
additional people
So for his family.
for his family? Oh, he's not making another one. Okay, so he's not making one for himself,
Mhm.
just for his family. So okay, so then that would be the 2/3 plus one. I guess you could put that inside parentheses, or make it 1 2/3, and then you could set it up like just add that, have 1 2/3 5 times
So okay.
as an addition problem is one option,
Okay.
or have it as a multiplication problem.
Okay. So then what would that look like?
Then that would be 5 times, and then in parentheses 1 2/3. Like, so what is that called? Like implied multiplication. I was a little quick sidebar. I was not debating. I was having a conversation with a guy that stumbled across one of my YouTube videos on order of operations
Mhm.
and PEMDAS, and he was claiming that um basically he wasn't following the order of operations, but he was saying that, but I appreciated his approach because he came with like some historical, like he was using other formulas
Mhm.
where like formulas from like physics and like engineering where they don't use parent grouping symbols, but they
Okay.
should. And they were saying that like, so this right here, 5 times 1 2/3, he would consider that implied multiplication.
Okay.
But what I realized is like, all right, we don't have that much to talk about no more because you're saying that 5 times with the X or the dot, 1 2/3 is different from this.
Mm.
He was claiming that those are different things. And then he actually referred me to like a video, somebody else's YouTube video where they were talking about why calculators give different answers for those order of operations questions
When
because
we
of
don't use
how they're
parentheses.
programmed.
Mm-hmm.
And then the lady that did that video, she like pulled up like old like textbook examples of how like when there's a division sign, um it's understood that the expression on the left side of the division sign, um and the expression on the right side of the division sign are kind of like equal. They would be, that's like the numerator and denominator instead of it being
Oh, like
about,
grouped.
yeah, they're grouped even without the parentheses.
Mm-hmm.
And but what I was saying to him was like the order of operations like removed, that's ambiguous. Like, so order of operations removes ambiguity,
Mm-hmm.
if you just follow the rules. But like, okay. But I thought that was interesting. I just wanted to
Right.
bring that up. That made me think of that. But yeah, 5 times 1 2/3.
Mm-hmm.
Um, but then how will we multiply? So then how do we multiply that? Do we,
We can do distributed property.
right? Yeah. Or if you want to, yeah, see, this is why, like for parents, This is why you need to learn like as many methods as possible because you want to have options. Like I might just convert that to an improper fraction, the 1 2/3,
Okay.
and then multiply that. But I would convert 5 to a fraction. And that's a good skill to understand that you can convert any whole number or integer, negative number to a fraction by just giving a denominator of one, and then you multiply them like they're two fractions. That's
So
another way to do it.
so you said you would multiply 5/1 times 5/3?
Yes.
Okay. So we got 25/3,
Hmm.
and then we got 5 plus 10/3. Now this is gonna be an extra step because now I gotta add 5 and 10/3. So whenever I think of trying to turn a whole number into a fraction in this way, I always think about what two numbers can I divide where the denominator is 3 and it gives me 5.
Hmm.
So I know that would be 15/3. But that's my thinking.
Yeah.
I still got the same thing, 25/3.
So,
Um,
so
Go
you want to
ahead.
convert? You want to convert it?
Yeah, we can.
Convert
Yeah.
it. So we know the number of cups. Like in the other problem, like um, so how many thirds? How
Mhm,
many groups of 3/3 do we have? How many whole cups? Every 3/3 is a whole cup.
mhm,
See, this is the concept, right? So this is the concept. So it's easy. It's easier to model if you understand that concept. Like how many whole cups are there in 25/3?
mhm,
So every 3/3 is a whole cup. So 3/3, 6/3, 9/3, 12/3, and so on. If you go
mhm,
up to, so then hopefully the child realizes, like, well, wait, if I'm just counting by threes, 24 is a multiple of three.
mhm,
So that would give me eight. 24/3 is eight. That's eight whole cups. And then how many thirds I got left over? I got one cup left, 1/3 of a cup left over.
mhm. Yep. And I thought about this in terms of ratios as well. Like this is fourth grade, but I was thinking about it in terms of sixth grade too. So like if they would have did a table, like I had tea, and then I had the lemonade, and then let's say this was number of people. So with the tea, that would be 2/3 of a cup. With the lemonade, that's 1 cup, and then it serves one person. So then I can scale each of these. So I can multiply this times 5, multiply this times 5, and multiply this times 5, and I would end up getting to the same thing.
Scale. Yeah, yeah.
Hmm. But that's a sixth grade concept. So the fourth graders, those babies, they wouldn't be doing that. But it's just interesting that I can just take this same scenario and I can make it a ratios problem.
And to all the people that want to be entrepreneurs and are entrepreneurs, and part of the reason that you went into entrepreneurship is because you didn't like math in school and you hated math and you were trying to really part of you was trying to just avoid math. When you get to that point where you watch that video on YouTube or you read that book and it talks about scaling your company,
Mhm.
you got to understand that concept. The concept was scaling. That's all math. It's just algebra. What we just doing here with these ratios.
Mhm. All right. So we talked about a lot tonight. The point was for us to come together and talk about the standards for mathematical practice. So again, that is the skills that we're trying to develop in our students in the classroom. So I'm hoping that as parents or educators, whoever is watching this video, I'm hoping that you're thinking about how can we get students to start making sense of problems and persevering in solving those problems? How can we get them to reason abstractly and quantitatively? How can we get them to construct those viable arguments as well and then be able to critique the reasoning of others? And I'm going to let Professor Akil kind of give us a little wrap up. So, what's something that you want to leave the people with this evening?
Yeah, so as a parent, like just continue to support your child by, being willing to learn and being teachable yourself. and just make the investment. It's a great investment in yourself, and also just modeling that for your child by showing them that there's value in actually learning this. Because once they, that's one of the best things you can do for your child is, attempt to learn these skills on your own, because then you're showing them that it's important. Because you might be at the big age of 40 or 50 or 35 or 30 or whatever, like, and a lot of people are like, I already finished school, or I don't need to know that, or I'm fine in my station in life. But if you show your child, like, you're never too old to learn something new, then that says a lot. And the other thing I would say is, with these standards, I think all of us as parents should be aware of the standards that are being used, to this, or that are aligned and connected to the curriculum that our children are being taught. And don't let the standards intimidate you, because I know somehow, like, sometimes, like, the standards can seem intimidating because of all the numbers and the letters and everything, and it seems like, and even some of the language of the standards, like, students will be able to, and all of that, like, and you might not know some of the vocabulary like that's in the standard, but don't let that discourage you.
Right.
And just a lot of things in terms of mathematics in general, sample problems, examples, the standards, a lot of the literature, the curriculum. It might be intimidating when you read it for the first time, but you got to just stay at it, and just read it again, and then read it again, and read it again. Every time you read it, it's going to be more familiar. It's going to seem easier and more understandable. So don't just look at something the one time and judge it based on how you perceive it the first time you read it, because it's always going to be more difficult the first time you look at it. So just don't let that be a deterrent for you,
To piggyback off that, as you guys are coming across the different standards, if there's something that you don't understand, I'm gonna challenge y'all to use AI to help you. So
Mm-hmm.
I don't know how into Chat GPT y'all are, but one thing that you can do is you can put some things in the Chat GPT that you don't understand, and Chat GPT can kind of explain some things to you. Number
Yeah.
one. Number two, let's say that you guys are working on some homework and there's something that you guys are working on and you want more problems, you can type that into Chat GPT and it can create some problems for you as well.
Oh yeah.
So AI is here, you know what I mean? Like it's here. So let's use it to our benefit instead of to our detriment. Like a lot of times people are using AI as like this photo math and this cheat and it's getting you the answers, but the answer ain't even half of it. You know what I mean? Like the answer, that's the end of it. But the thing we need to focus on the journey is how do we get that? Because if we can figure out the answer and we can replicate that strategy, like Akil said earlier, we can solve any type of problem. Like once we build that critical thinking skill, once we get to the point where if we don't pop the balloon or find love, if somebody asks us a question and we know how to respond, you can respond in any situation. That's what we're building. We're building your experience. We're building your child's toolkit. So no matter what is presented to them, they'll be able to respond. They'll be able to construct arguments because they have experience with solving problems and providing you with evidence. So again, I love it when we come together because I know we're going to have a good conversation. I know that we'll be able to share something with the people that maybe they haven't even seen before, or maybe they haven't seen it in this way. So we'll continue to bring you guys good content as long as you guys keep showing up and, interacting with us. So we appreciate you guys and we hope that you appreciate us. As always, we really want you to kind of delve into all this math because all of you guys are capable of being young gurus as we bud and bear fruit. Until next time, peace.
Peace.